In this video, we'll cover 20 questions from the FAA private pilot written exam that you must know to ace your test. Let's jump in. In the Northern Hemisphere, if an aircraft is accelerated or decelerated, the magnetic compass will normally indicate. Magnetic compasses will show a turn to the north when accelerated on an east or west heading. Conversely, magnetic compasses will show a turn to the south when decelerated while on an east or west heading. One way to remember this is the phrase ANDS, which means accelerated north and decelerated south. Magnetic compasses will be correct when an aircraft is accelerated or decelerated while on a north or south heading. Therefore, the correct answer is C. On a turn from a northerly heading, the compass will, according to Chapter 8 of the Pilot's Handbook of Aeronautical Knowledge, when starting a turn from a northerly heading, the compass will lag behind the airplane. Conversely, while on a southerly heading, the compass will lead the turn. The correct answer is C. Refer to Figure 38. Determine the approximate landing ground roll distance. As illustrated, the pressure altitude is 5,000 feet. The headwind is calm, and the outside air temperature is 101 degrees. Refer to the area of the chart denoting the ground roll distance when pressure altitude is 5,000 feet. Since the outside air temperature of 101 degrees is well above the indicated temperature of 41 degrees, we need to make an adjustment to the ground roll distance to account for the increased air temperature. The chart indicates to increase the landing ground roll distance by 10% for each 60 degrees in Fahrenheit temperature increase above standard. Since the standard air temperature assumed at 5,000 feet is 41 degrees and the current indicated air temperature is 101 degrees, we can see the current temperature is 60 degrees above the standard temperature of 41 degrees. Given the increase in temperature, we would increase the landing roll distance by 10%. 10% of 495 is 49.5. Add 49.5 to 495 to get the adjusted landing ground roll distance of 544.5 feet. The best answer is B, since that is the closest to the exact ground roll distance of 544.5 feet. When the course deviation indicator, also known as the CDI needle, is centered using a VOR test signal, the omni-bearing selector and the to from indicator should read. Review the Aeronautical Information Manual, Chapter 1-1-4, under the section titled VOR Receiver Check. With the course deviation indicator centered, the omni-bearing selector should read 0 degrees, with the to from indicator showing from, or the omni-bearing selector should read 180 degrees with the to from indicator showing to. The correct answer is therefore C. What is the estimated time en route for a flight from Denton Municipal Airport in Area 1 to Addison in Area 2? The wind is from 200 degrees at 20 knots. The true airspeed is 110 knots, and the magnetic variation is 7 degrees east. To solve this problem, we first need to calculate the true course and distance between each airport. Using the ForeFlight app, we can use the ruler function to find the true course of 128 degrees and the distance of 22.5 nautical miles. We then need to find the ground speed given the wind conditions. We can find the ground speed using the heading and ground speed function on an E6B calculator. Using an E6B calculator, enter the wind direction of 200 degrees, the wind speed of 20 knots, the true course of 128 degrees, and the true airspeed of 110 knots to find the ground speed of 102 knots. Finally, we need to use the lag time function to find the time en route for the flight. Remember, the distance between Denton Municipal Airport and Addison was 22.5 nautical miles. Enter the distance of 22.5 nautical miles and the ground speed of 102 knots to find the estimated time en route of 13 minutes and 13 seconds. Therefore, the correct answer is A, 13 minutes, since that is the closest answer to the exact flight time of 13 minutes and 13 seconds. I'll now turn it over to Jane, who will go over the rest of the questions in the video.
Thanks, Nick. Moving on to question 15. The VOR receiver has the indications shown. What radial is the aircraft crossing? Let's take another look at the VOR simulator to visualize this problem. To find the radial, turn the OBS knob until the CDI needle centers and there is a from indication showing. In this case, the aircraft shown in the chart is on the 030 radial of the VOR. Let's now turn the OBS knob until the CDI needle centers on a heading of 210 to match the VOR indication shown in the question as illustrated. We would be flying towards the 210 radial of the VOR. Notice how the 2 from indicator shows a 2 indication. VORs can be a bit confusing at first, so let's look at another diagram to illustrate. VORs transmit radials outward in all 360-degree directions similar to the compass rose shown. From the previous example, we would be flying towards the 210-degree radial and there would be a 2 indication shown. However, we are still flying on the 030 radial since that is the 180-degree reciprocal of the 210 radial as shown. Remember, the 2 from indicator was showing a from indication when the CDI needle was centered on a heading of 030. The aircraft would therefore be crossing the 030 radial if the VOR had the indication as shown in Figure 5. Approximate ground roll distance necessary for takeoff under the following conditions. The outside air temperature is 90 degrees, the pressure altitude is 4,000 feet, takeoff weight is 2,600 pounds, and there are 20 knots of headwind. To find the answer to this question, start by drawing a line up from the 90-degree outside air temperature line at the bottom of the chart. Draw the line up until it intersects the 4,000 pressure altitude line. Then draw the line to the right and then down until it meets the takeoff weight of 2,600 pounds as illustrated in the middle of the chart. Continue drawing the line over to the right until meeting the wind component section. Since there is a 20-knot headwind, draw the line down and to the right until it intersects the 20-knot wind line near the right of the chart. Finally, draw the line to the right. Notice that the line ends up right under the 1000 figure on the far right-hand side of the chart. This means the approximate ground roll distance based on the given set of conditions is 800 feet. The correct answer is C. If a flight is made from an area of low pressure into an area of high pressure without the altimeter setting being adjusted, the altimeter will indicate. To illustrate, elevation at Denver, Colorado is 1 mile high and Seattle, Washington is at sea level. The air pressure is lower in Denver than it is in Seattle because Denver is at a higher elevation. The average air pressure in Denver is roughly 12 pounds per square inch versus at sea level where the air pressure is usually about 14.7 pounds per square inch. One way to remember how air pressure affects altimeters is high to low, look out below, meaning that if you fly from an area of high pressure to low pressure without adjusting the altimeter setting, then your aircraft would be at a lower altitude than the altimeter is reading, and thus the aircraft's altimeter would indicate an altitude higher than the actual altitude above sea level. Conversely, if you fly from an area of low pressure to an area of high pressure without adjusting the altimeter setting, then your aircraft would be at a higher altitude than the altimeter is reading, and thus the aircraft's altimeter would indicate an altitude lower than the actual altitude above sea level. The correct answer is A. Arrows that appear on the end of the north/south runway indicate that the area. According to Section 2-3 of the Aeronautical Information Manual, the portion of runway behind a displaced threshold is available for takeoffs in either direction and landings from the opposite direction. This question can be a bit tricky since it may seem like answer B could be the right answer. However, displaced thresholds can only be used for landing from the opposite direction. So in this case, a pilot could taxi and take off in the area with the white arrows just before runway 36 but could not use it for landing on runway 36. A pilot could use this area for extra landing roll when landing on runway 18. The correct answer is C. What is the maximum amount of fuel that may be aboard the airplane on takeoff if loaded as follows? On the exam, you will see weight and balance charts as shown. For the first question, we are given the empty weight of the airplane, pilot and front passenger weight as well as the weights for the rear passengers and baggage. The chart tells us that the oil weighs 15 pounds. To start, we need to add all the weights together as shown. After adding the weights together, we can see that the weight of the airplane is 2,060 pounds. Next, we can see from the weight table that the max allowable weight is 2,300 as illustrated by the arrow in the chart. We then need to subtract the weight of the airplane from the max weight allowable to find how much weight capacity is left for extra fuel. The max weight of 2,300 pounds less the airplane weight of 2,060 pounds equals 240 pounds. Fuel weighs 6 pounds per gallon, so we would then divide 240 by 6 to find the max fuel amount of 40 gallons. Plane and determine which category is applicable. During your private pilot written knowledge test, you will be given a booklet with weight and balance tables similar to the ones shown. To solve this problem, we would use a straight edge and draw lines from the corresponding weights on the left of the chart. We would draw the line over to intersect the line that corresponds to the weight we are trying to solve for. To find the weight for the pilot and front seat passenger, draw a line just above the 300 number on the left since the weight is 310 pounds for the front passenger and pilot. Draw the line from the left to right until the line intersects the pilot and front passenger line in the chart. We then draw a line down to the bottom of the chart to find the aircraft's moment divided by 1,000. We can see the moment divided by 1,000 is about 11.7 for the pilot and front passenger. Repeat the same process for all the other weights. The moment divided by 1,000 for the rear passengers is 7 and the moment for the fuel is 11.2 to be exact. It can sometimes be difficult to find the exact figures on the weight and balance tables, so try to get as close as possible, but sometimes you can round up or down slightly and will still get very close to the right answer. We then add all the moment figures together and the weights to find the center of gravity, abbreviated CG. The weight is 1,999 pounds and the CG is 81.2. We then draw two lines. One from the left just under the number 2,000, since the airplane's weight is 1,999 pounds. Then draw a second line up from the bottom of the chart just to the right of the number 80, since the airplane's moment divided by 1,000 is 81.2. The lines intersect at the upper right-hand range of the utility category. Therefore, the correct answer is C. The airplane's moment divided by 1,000 is 81.2 and the aircraft is in the utility category. What effect does a 35-gallon fuel burn, main tanks, have on the weight and balance if the airplane weighed 2,890 pounds and the moment divided by 100 was 2,452 at takeoff? We know that 35 gallons of fuel weighs 210 pounds since 1 gallon of fuel weighs 6 pounds. You can see from the fuel weight table that the moment for 35 gallons of fuel is 158. To summarize, the aircraft's moment at takeoff was 2,452. We can subtract the fuel's moment of 158 to get the aircraft's moment after 35 gallons of fuel burn. The aircraft's moment after the 35 gallons of fuel burn is now 2,294. The aircraft's weight is reduced from 2,890 pounds to 2,680 pounds. Notice from the figure to the bottom right of the chart the aircraft's moment limits for a given weight. Since the aircraft is now 2,680 pounds, we can see the 35-gallon fuel burn would reduce the aircraft's weight by 210 pounds and the center of gravity, CG, is now aft of limits. If 50 pounds of weight is located at point X and 100 pounds at point Z, how much weight must be located at point Y to balance the plank? To solve this problem, we need to find the moment for points X and Z on the plank. The formula to find the moment is weight multiplied by arm. We can find the moment for point Z by multiplying the weight of 100 pounds by the arm of 100 inches. The moment for point Z is 10,000. We will use the same formula to find the moment for point X. 50 times 50 equals 2,500. We then subtract point X's moment of 2,500 from point Z's moment of 10,000 to get 7,500. We would then divide 7,500 by 25 since that is the length of point Y from the center of gravity. 7,500 divided by 25 equals 300. Thus, we would need to place 300 pounds at point Y to balance the plank. The radius of the procedural outer area of Class C airspace is normally. According to Chapter 3 of the Aeronautical Information Manual, Class C airspace normally has a procedural outer area of 20 nautical miles from the primary Class C airspace airport. Refer to the density altitude chart in the top left of the screen. What is the effect of a temperature increase from 35 to 50 degrees Fahrenheit on the density altitude if the pressure altitude remains at 3,000 feet MSL? To find the answer, draw a line up from the 35-degree section under outside air temperature to the 3,000-foot pressure altitude line highlighted by the yellow line. Then move over to the left side of the chart to see the density altitude is just under 2,000 feet. Do the same thing at the 50-degree marker and draw a line up to the 3,000-foot pressure altitude line and over to the density altitude side of the chart. You can see the density altitude increases to just under 3,000 feet at an outside air temperature of 50 degrees. So that means there would be a roughly 1,000-foot increase in density altitude given the increase in air temperature from 35 to 50 degrees and assuming the pressure altitude remains at 3,000 feet above mean sea level. What are the basic VFR weather minimums required to take off from the Onawa, Iowa, K-36 airport during the day? Notice the Onawa airport highlighted by the yellow box in the chart. The airport is an uncontrolled airfield in Class G airspace. The required VFR weather minimums for daytime flight in Class G airspace is 1 statute mile and clear of clouds, according to the Aeronautical Information Manual. The correct answer is C. If receiver autonomous integrity monitoring capability is lost in flight. See Chapter 1 of the Aeronautical Information Manual in the section on navigational aids to find that without RIM capability, the pilot has no assurance of the accuracy of the GPS position. What is the crosswind component for a landing on runway 18 if the tower reports the wind as 220 degrees at 30 knots? To find the answer to this question, first subtract the runway direction of 180 degrees from the wind direction of 220 degrees to get 40 degrees. Since the wind speed is reported at 30 knots, draw a line on the 30-degree arc in the diagram, as highlighted by the red dashed line in the chart. Then draw a line down from the area where the wind angle line and wind velocity arc intersect. The crosswind component is just to the left of 20 degrees, so we can see the crosswind given the conditions is 19 knots. The correct answer is A. Determine the density altitude for these conditions. The altimeter setting is 30.30, the runway temperature is 25 degrees Fahrenheit, and the airport elevation is 3,894 feet above mean sea level. The first step to solving this problem is to adjust the pressure altitude based on the current altimeter setting, which in this case is 30.30. Notice the pressure altitude conversion factor of -348 for the altimeter setting of 30.30. We need to subtract 348 from the airport elevation of 3,894 feet to get the adjusted pressure altitude of 3,546 feet. Then draw a line up and to the right roughly halfway between the 3,000 and 4,000 foot pressure altitude lines, since 3,546 feet is roughly halfway between 3,000 and 4,000. Next, draw a line up from the 25-degree outside air temperature line at the bottom of the chart until it intersects the red pressure altitude line. Finally, draw the line over to the left to find that the line ends up just above the 2 in the chart. Since the figures on the left of the chart are showing the approximate density altitude in thousands of feet, we can see the best answer to this question is 2,200 feet, since the orange arrow is pointing just above the 2,000-foot density altitude line on the left of the chart. The segmented circle indicates that a landing on runway 26 will be with A. As you can see from the figure on the left, a pilot would make a right-hand traffic pattern for runway 26. The traffic pattern for landing on runway 26 is highlighted by the orange arrows. The wind direction is indicated by the red arrow and windsock illustrated in the chart. As you can see, the wind would be coming from the right and the pilot would be flying into a headwind, so the correct answer is A. Right quartering. Thanks for watching the video. Please like the video and subscribe for more flight training and aviation-related educational videos.